In this video we are going to learn about combinational logic gates. We are going to combine AND and OR gate with NOT. Then it's together we are calling it as combinational logic gate. So very simple, here the AND is NOT. That means always we'll be getting the output opposite to AND gate. Symbol, you need to be very careful here. When there is a NOT, it is indicating the NAND gate, right? So when you are analyzing circuit, sometimes we might assume this as AND gate because we are familiar with AND. No? Always we need to make sure, right? Always they won't represent like this. This is the symbol and then the NOT. So NAND gate. Here after feeding input, we are getting the output and converting everything using NOT. Here feeding time itself, each and every input is NOT. Then we are deriving the output, right? Now it is very clear, NAND gate is always opposite to AND gate. Now compare the output here. Now this is the AND gate output. No, we know, no, always both switches need to be on, no, to get 1. So NAND is AND and NOT, no, so here the opposite. This is only you have to remember, right? NAND is opposite to AND. Other than that, you no need to memorize all these input combination, everything. If you know this, you can take this, right? Both ways possible, right? Now it is very clear, no? Right? You are not very familiar with these circuits now. So therefore, everything you should be able to clearly understand how this circuit is equivalent to this. Then NOR gate, O and NOT, right? Same, O gate output is feed to NOT gate. So this is the symbol. So this is not O gate, this is a NOR gate. So NOR gate is opposite to O. We know, no, O only 0 0 only we get 0. All other combination 1, no, because this switch or this switch on, you will be getting output. So opposite to O means this is the output. So that's all you have to remember, right? No need to memorize all these gates, only basic 3 gates enough, right? NOR is opposite to O, NAND is opposite to AND. Now it is clear, no? Either way is possible, right? Now we can see few exercise. Even though it is look like simple, once you understand the theory is very simple, otherwise you get confused. Write down the respective value for Y when x is equal 0, when x is equal 1, right? We'll take one scenario, x is equal 0. Now what will happen? If you feed here x 0, it will go to the NOT gate and here it become 1, no? Right? Now it is the AND gate, no? A, we don't know 0 or 1, right? So therefore no need to get confused. Whatever the value you can assign. For example, I am assigning A is equal 1, right? Now the condition is x is 0. Now here 1. I have assigned 1 here. Then you see 1 and 1, you will be getting 1 here, no? Then you compare this output with A. Equal, no? Here also 1, here also we gave 1. So that means always output is depends on A in this situation, right? For example, let's say A is equal to 0. Now here you got 1. AND gate, no, 1 and 0, the output is 0. Then again we can compare the output, here also 0, here also 0. Then finally we can make sure output is always depends on A here, right? Now up to here we need to see here, no, right? Now here it is A, we fed 0, no, right? Now same the x value is fed here 0. It is a AND gate. So whatever the B value, if this is 0, definitely this is going to be 0, no, right? Then this is 0. Then 0 and A is a O gate, right? If A is 1, you get 1 here. If A is 0, you get 0 here. So finally the Y is equal to A's value, no? So therefore we write here A. When x is equal 0, output is equal to A. When x is equal to 1, now here assigning 1, then this is not, no, then you will be getting 0 here, right? Then whatever the value A here, it is useless AND gate. No, finally it will be 0. Here it will be 0, right? 0 is fed here. X is equal 1, directly we are feeding here. No, so whatever the value here B, if B 1 you get 1 here, if B 0 you get 0. So depends on the B. Then here you will be getting the B value. Then B or 0, definitely whatever the value B contain here, that only comes to the output, right? B or 0. No, so if B is 1 mean here it will be 1, B 0 mean it will be 0. So when X is equal 1, here the output is B. So A comma B. Therefore all these kind of questions we need to assign it and see whether the output is equal to A or not. Equal mean we say A, if not equal mean opposite mean put A bar. Right, now for this circuit, when B is equal 1 for Q, they are asking the value. Now see, when B is equal to 1, fine, this is an AND gate. No, so B is confirmed, no, fix 1. Then if A is 1 you get 1 here. No, if A is 0 you get 0 here. No, so the output is depends on A value. So Q is equal A. Then for Q, when A is equal 1, when A is equal 1, what is the value for Q? When A is equal 1, now see here, this is AND gate, this is NAND gate, not, right? If A is equal 1, right, we don't know whatever the value here B, no, right? If B is 1, the AND gate, you will be getting 1, but it is NAND, no, then final output is opposite to that. Here AND is giving 1 mean the NAND is giving 0. Always you AND and not it, then it is easy for you, no need to memorize anything. Right, now let's say A is equal 1, then assume B is equal 1, right? 1 and 1, output is 1. Since it is a NAND gate, it is sent through the NOT, no, so then that becomes 0. So it is getting always opposite to B value, right? A is equal 1, let's say B is equal 0. So he's first you take the AND, 1 and 0, 0. Because of NOT, final output will be 1. Always opposite to B. Therefore Q is equal B bar. So remember, certain times this way also possible. This also equivalent to B bar here. This symbol also you can use, but most of the time always the B bar will be used, but this is also possible. Right. Now see this one. What should be the gate A? To give this output, what should be the gate A, they are asking. Now X0, Y0. Here it is given X bar, Y bar, here X0, Y0. Right. Now if X0, Y0, this is going to be 0. Right, this is going to be 0. It is fed here, we don't know what is the gate here, right? Then X bar, Y bar means opposite to 0, 1, 1. Then it is fed here 1. Then here 1, here 0. Right, here 1, here 0. Then you see the output, it is given 0 on output here. So that means here coming through NOT gate, no. So therefore definitely here the value should be 1. Then after not only becoming 0, no. For this output, first of all this need to be 1. So this to be 1, this has to be OR gate, no. Why? Here 1 and 1, 1. Here 0 and 0, 0. For 1 or 0, no, you will get 1. If it is AND gate, what will happen? 1 and 0, here you get 0. Then the output will be 1. Then this will be 1. So looking at one output itself, you can decide this is a OR gate. This is the OR gate. Right? Then the value for C, right? X is equal 0, let's say y is equal 0, then always C is x dot y, no? Whatever the output coming here, no issue for this, no? We are taking the output from here, right? That is, they want to examine whether you have understood clearly how these logic gates work. So they are asking the output for C, that is not depend on any of this. The output is depend only on this. Therefore product of x and y, x dot y. Right, here A is equal 1, B is equal 1, C is equal 0. What is P and Q? Very simple, no? A is equal 1, B is equal 1, right? 1 and 1 here, no? So here it is a OR gate. So 1 no 1, definitely you are getting 1. Here the not, no? So that means there is a NOR gate, opposite to O. So 1 and 1, 1. Since it is a NOR gate, then output will be 0. Then P will be 0. Right? We'll see Q. This is 1. This is 1. So then here the output you are getting 0 here. Output here you are getting 0. Then that is fed here. Then C is equal 0. So if you fed 0 here, it's a NOT gate. No, here this become 1. So here 1 and 0. Here you get 1 and 0. Always in AND gate 1 and 0 output will be 0. But again here this shows so NAND gate, no, not, no. So then 0 become 1. So then P is equal 0, Q is equal 1. So therefore don't just listen to it. You should be able to go through this circuit and see whether you can understand how the P becomes 0, Q become 1. Very simple. Just apply the theory, see the gate, what is the output, that's all. Even if they provide like 5, 6 integrated logic gate, one by one you need to just feed it and go, that's all. Proper understanding only very important. Now see here, to draw an equivalent circuit, right? Draw an equivalent circuit. So first they have given this. Now see here, A, B, right? Always you, because this is an open circuit they have given, you can take any value and see. So I am taking A1, B1. Then not is given here. So then this becomes 0. B1 this becomes 0. Then 0 or 0, 0. So the input is 1 and 1, you are getting 0 here. Input is 1 and 1, you are getting 0 here. Immediately you can remember, right? Just you compare O and AND gate, right? First you take the O gate, you know for all combination you get 1, only for 0 0 you get 0. Therefore in NOR gate for 0 0 only output is 1. But in this case we are feeding 0 0 here, you are getting 1. If you feed 1 1 here, you are getting 0. So only the NAND gate gives 1s and 1 0. Clear? Now here this is AND and opposite, right? Now if you feed A is 1, B is 1, so you will be getting here A 0, B 0, then output also 0, right? So A1, B1 you are getting output 0. Now similarly you see here A1, B1, so AND gate give 1, because it is not, then you will be getting 0. Similarly if you provide 0 0 here, here 1, here 1, here 1, so same here you are providing 0 0, AND gate will give 1, sorry, 0 0, AND gate will give 0. So here not is there, no, so not gate is connected. Then what will happen? Opposite to that, output is 1. So therefore that's what I am always asking you to not to remember everything. AND gate, OR gate, NOT gate enough. NAND and NO you can assume. Opposite to AND, here you know 1 1 to get 0. Normally the NAND gate give that kind of output. So immediately you can identify after feeding 1 1 and 0 0 whether it is giving the same result. So this is equivalent to this. Draw an equivalent circuit using NO. Now this is the circuit. They are expecting us to redraw this using NO gate. This also same. You take A1 B1. What will happen? Here this becomes 0, no? Right? Then B1 1 and 0 0. So if you feed 1 and 1, it should get the 0 value. 1 and 1 should get the 0 value. Right? Here we fed 1 here. Here you fed 1. This becomes 0. This becomes 1 and 0 AND gate is giving 0. Now we need to use NO gate, no. For example, now the NO gate is used. Right? For NO gate, same input should be given, 1 and 1. Right? Here also 1 and 1, we are getting output 0. Now we need to feed same thing using NO gate. That's what the question asks. So you are giving 1 and 1. So what will happen here? You are feeding 1 here, right? To make it 0, OR gate output should be 1, right? So here this to become 1, A1 B1, so here becomes 0. So it's a 0 and 1, 0 and 1, you will be getting 1. Since it is not, again output will be 0. Therefore these things are very simple, right? As they ask this, you draw the NO gate and see. Now NO gate, I want to make this 0. So to make this 0, here 1 comes also, 1 comes opposite to 0. Even without this also you can directly feed, no problem. By A1 B1, so 1 and 1 OR gate 1 is not, therefore it is given 0. So for the 1 and 1 it is giving 0. 0 and 0 also same. 0 and 0 0, but it give 1. Here also 0 and 0. What will happen? Here if you place a 0 here, this become 1. If you place 0 here, what will happen? Will you get 1 here? No. 0 and 1, again this becomes 0. That's what at least you need to apply 2 condition and see. Otherwise without this, only for the 1 and 1, without this it is equivalent, but with this condition it is not equivalent. So that is the main reason we need to put this. All combination we need to see, right? If you put 1 and 0 here, this will become 0. If here 0 and 1 also, this need to become 0. So similarly here 1 and 0, so you get 1 here, here you get, if you feed 0 here you get 1. So 1 and 1 OR gate, it will give 1, because of not it's 0. Then again we interchange it and put this 0, this 1, right? This 0, this 1. Then this becomes 0, this becomes 0, then 0 0, it is 0 because of the NOR, it is 1, right? Likewise we need to check whether these conditions are matched with this, right? Now it is very clear. If you understand the theory clearly, you can just apply it and see, right? Because they are clearly same with NO gate, no, so you have to draw the NO first. and for all these combination, whatever the output you are getting here, this also should give the similar output, right? Now it is very clear. In next few videos we can see how to derive Boolean expression, and according to the Boolean expression how to draw logic circuit, and how we can solve practical problem using logic gate. Stay tuned for next few videos. Thank you.